Okay, so now we know about the built-in collection types that Python 3.7 provides. The list, tuple, set, and dict. We're also going to include the stir, because the stir can be treated as a collection of one-character stirs all concatenated together. And I'd like to do an overview and review of the different kinds of characteristics that these collection types have relative to each other. First of all, a quick review of programming in general. To write a small to medium-sized program, you are going to get some input from somewhere, and we saw that that input might come from a user, that input might come from a file. You might have a program that receives input both from files and from the user. You can get data from other sources as well. You can get data from a database system or various sensors or things of that kind. Once you've gotten your input read in and organized and cleaned up, then you're going to process the data in whatever way makes sense for what you're trying to do. And after you have processed your data, you're going to need to produce some output for some human to look at. Now, that output might be directly to the user's screen, or that output might be stored into a file, that output might be written back into a database system, that output might be sent off to a printer to display, to produce some physical documents that somebody can read. To keep track of and organize the data, we usually put that data into some kind of collections. And the basic built-in collections, as we've described, are the stir for character strings, list, tuple, set, and dictionary. Now, strings are where most things begin and end. That is, when we're getting input, we're almost always getting strings. When the user types characters on the keyboard, what the program receives is a sequence of characters that's stored into a string. And that's true whether the characters the user types are intended to represent things like words or sentences or paragraphs, or the things the user types are intended to represent numbers like billing amounts or payment amounts or temperatures or things of that kind. What comes in from the user, and generally what comes in from a database system or what comes in from a text file, are strings. We often then do things to simplify and reorganize those strings to get the strings broken down into the pieces that we can make use of. We often do things like stripping the new line character off the end of a string. We may also strip spaces off the beginning of the string. We often split up a string into separate words or separate fields so that we can deal with a list of individual words or individual fields contained within the string. And we may then also convert certain fields in the strings to things like int or float values. Okay? Once we have done our processing, if we have a bunch of int and float values that we need to report back to a user or store in a database or write into a file, we're generally going to need to convert those integer and floating point and Boolean values back into strings that we can store and display. All right, so here are these 5 collection types: stir, list, tuple, set, and dictionary. It's necessary to know how to define empty occurrences of each of these, and also how to define one item, single item versions of these, as well as multiple item versions. All right, well, an empty string is really easy. You just can use a pair of single quotes, or if you want, you can use a pair of double quotes. All right, now there I forgot to type a space between my equal sign, my single equal sign and the string, but that's okay. That's just a That's just I made a stylistic, I don't really want to call it a mistake, but I made what for myself is a stylistic mistake, a typo. I normally put a space between the single equal sign and the double quote, but there my fingers just slipped on the keyboard. I can also use the stir conversion function with no argument. That also will create for me an empty string. All right, now to create an empty list is simple. You can just say, I'm going to call this M1. Use a pair of square brackets, open bracket, close bracket. That is an empty list. It is a list as confirmed by the type function, and it is empty as confirmed by the len function, and if you display the empty list itself, the shell displays its representation as just an open and closed square bracket. A tuple, an empty tuple, can be represented as just a pair of empty parentheses, or it can be represented by typing the tuple conversion function. For an empty list, you can use the list conversion function with no argument. Okay, so here's T1. It's an empty tuple. Its type is tuple. Its length is 0. For an empty set, you cannot use empty curly braces, as you might be tempted to do, because curly braces are also used to define a dictionary, and the empty curly braces are treated as defining an empty dictionary. So this won't work. And in fact, I'm going to hit Control-C here rather than hit the Enter key. What we need to do is to say set1 gets set, and now we have an empty set. Its type is set, and its length, its number of items, is 0. And then finally, for an empty dictionary, we can just use empty curly braces. That's a dictionary, and it is empty. All right, so len here is actually iterating through the dictionary, technically iterating through the keys of the dictionary, and telling me how many keys there are in the dictionary. But of course, the number of keys is the same as the number of key value pairs, and I'm getting told that this dictionary is empty. All right, so these are mechanisms in this first column on slide 5, are mechanisms for creating empty instances of these 5 collection types. For creating one-item versions of these collection types, most of these are pretty straightforward. If I want to create a string containing one character, that's no problem. I just put one character in quotes, or double quotes, or triple single quotes, or triple double quotes. And likewise, if I want a list that just has one item in it, I can create a list in square brackets that just has one item in it. Now, in this particular case, I've created a list containing one stir as its item. So the type of M2 is list. The len of M2 is 1. The type of the first item in M2 is stir in this case. Okay. And the example on slide 5 shows a list containing one int value as opposed to a list containing one stir value. For creating for creating symbols, I'll get this right eventually. All right. For creating single item collections, the only one that's strange and annoying is a single item tuple. If I say T2 gets But earlier we had said T1 gets open and close parentheses, and that worked fine. That created a tuple. That created a tuple that was empty. But if I say something like this, T2 gets, and then 5 in parentheses, this is what I might very well be tempted to do, to create a tuple with one item in it. Unfortunately, the parentheses are used for multiple different things. They are not only used to define a tuple. Parentheses are also used in arithmetic computations to either clarify or redefine precedence and associativity among the operands in an expression. And in fact, if I just put a number in parentheses, all that really does is to define that number, and the parentheses are just redundant, really, in this case. So if I ask for the type of, parentheses 123, well, the parentheses there that I've highlighted around the 123, those parentheses are not having to do with creating a tuple. Those parentheses are having to do with specifying precedence in an arithmetic expression. But in this case, the arithmetic expression is just the constant int value 123. So those parentheses really are redundant. And what I have here is an int, not a tuple. Okay, so by saying T2 gets paren 5 paren, T2 is now just an int with the value 5. It is not a tuple. In order to force the parentheses to be recognized as tuple notation, I have to do this ugly thing of giving my opening parenthesis and then following that by a comma. That comma flags the Python shell and says, hey Python, I'm defining a tuple here, not just an arithmetic expression, and this tuple is going to contain a single value. So here's T2, its type is tuple, and its length had better be 1. All right, so this is a tuple of one item, and you define it with this ugly parenthesis and trailing comma, and it also displays as parentheses with a trailing comma after that first value. Okay, so that is a nuisance that you simply have to remember. Now, when I define a set of one item, that's easy. Here I'm defining a set just containing the single item value 1. All right, so set 2 is a set, and its size is just 1. The only difference between defining a set and defining a dict is that you do have to use a colon followed by a value associated with the key. So D2 gets curly brace. Here I'm defining A, the string A is my key, and 5 is the value associated with that key. And now D2 is a dictionary, and its len is 1. Okay, so we've taken a look at how to define empty collections of all these built-in types, and we're considering stir as a collection here. So we've got stir, list, tuple, set, and dict collections. And we've looked at defining single item collections. Again, stir, list, tuple, set, and dict. And the only two sort of oddball cases to keep track of are you have to use the conversion function named set with parentheses to create an empty set, and that is also how the empty set is displayed. and you have to use this ugly parenthesis and trailing comma to define a single item tuple. All of the other cases are just what you would expect to do from a little bit of experience anyway. Defining multi-item strings, lists, tuples, sets, dictionaries is straightforward. Now, we also described various important characteristics of these collection types. Is the collection type mutable? That is, can you change an item within the collection? Can you remove an item from the collection? Can you add an item to the collection? And what we saw is that the stir and tuple collection types are immutable. All right, you cannot say something like S3 gets hello, and then say S3 sub 0, sorry, typo, sub 0 gets a J. Here I'm attempting to change hello to jello, but it's not going to work. All right, and similarly for a tuple. T3 gets 3, 5, 7, 12. T3 sub 2, let's say, gets -1. All right, T3 sub 2 is this 7 here, and that also is not going to work. However, lists, sets, and dicts are mutable. For a list, we can do an ordinary assignment to an item. So I can say M3 gets 1, 2, 3, 4, 5, let's say. M3 sub 3 gets -3. All right, now MC sub 3 is actually this 4 here, and I can successfully change that 4 to a -3. I also have various other ways of modifying the contents of this list. I can say M3.pop. That modifies the list. Okay, and I can say M3.append and a value, and that modifies the list. So there are many ways that I can modify the contents of a list. A list is mutable. A set is also mutable. Now, a set is a little less conveniently mutable in some ways than a list. So if I create a set containing 1, 2, 3, 4, 7, 8, 9, there's my set. I cannot say S3 sub 2 gets 12 because a set is not a sequence, and so I can't do subscripting in a set. But what I can't, well, let me go ahead and do this and I'll get yelled at. So I can't do subscripting in a set, but what I can do is I can say S3 dot delete 3 to get rid of the value 3. Sorry, S3 dot remove. S3 dot remove 3. And so the 3 is now gone, and I can say S3 dot add 12, let's say. Okay, so there's no one-step replacement of an item in a set, but I can remove that item and I can add a different item, which is effectively the same thing as replacing that item with something else. Similarly, for a dictionary is mutable. If I have an empty dictionary, let's start with an empty one, then I can add a new key value pair to that dictionary by saying D3 sub Joe gets, maybe this is Joe's age, 45. All right, so I've now modified D3. I can also modify the value associated with that key. All right, so Joe has had a birthday, and now Joe is 46. Or I can say something like this. I can say D3 sub Joe plus gets 1 for Joe's next birthday. Remember, this is the same thing as saying D3 sub Joe gets D3 sub Joe plus 1. So we're going to obtain the value associated with the key Joe, which is 46. We're going to add 1 to that, which is 47, and we're going to store the result back as the new value for D3 sub Joe. And this plus gets operator is just a convenience for the same thing. So D3's Joe key now has 47 associated with it. So stir and tuple are not mutable, or are immutable. List, set, and dict are mutable. Are these things iterable? All of them are iterable. That is, we can use all of them in for loops. We can use all of them with conversion functions to convert this the sequence of values they contain into some other collection type. A dictionary has 3 different ways of iterating through the dictionary. You can either iterate through the keys, or through the values, or through the items. And if you iterate through the items, what you get back is a tuple consisting of key comma value for each of the items that exist within that dictionary. Which of these things can directly be sorted? Well, it turns out that only a list among these things can be sorted. Now, stir and tuple cannot be sorted because they are immutable. So the fact that these are immutable implies that you can't sort them. Set and dict, on the other hand, cannot be sorted because they are not ordered in the first place. Items in a set are not ordered, therefore it doesn't make sense to talk about reordering the items within a set. Likewise, items in a dictionary are stored in the order of key creation, and sorting is not allowed. Now, we could argue that we could make sorting allowed for dictionaries, but sorting is not allowed. Alrighty. So we've taken a look at how to create these 5 kinds of collections: empty ones, single item ones, multi-item ones. And we've taken a look at which of these are mutable, which are iterable, and which are sortable. Here we have a few more examples. If I say stir1 gets this, and then I say stir1 gets, plus gets is a test, should this work? Let me think now. We just got done saying that strings are immutable, and yet what we're attempting to do here is to append is a test to the end of that string. Am I going to get yelled at or not? Interesting, I don't get yelled at, and if I look at stir1, interesting, stir1 this is a test. So this may seem like I've broken the rule. I've claimed that stirs are immutable, and yet I changed the string. Well, actually, technically, I didn't change the string. What I did was I changed this variable name to refer to a different string. Because remember, let me start this over again. Let me say stir1 gets, if I could type, stir1 gets this. So there's stir1. And now let me say stir1 plus gets space is a test. Remember that what this really is what this plus gets is an abbreviation for is saying stir1 gets stir1 plus space is a test. Now, stir1 plus is a test is valid, because what it says is obtain the stir that stir1 currently refers to and append to that, or concatenate to that, this other string is a test. Plus is a perfectly valid operation between two strings, and it means to produce a stir that is the concatenation of those two stirs. So what I'm saying here is take the value that stir1 refers to now, concatenate that with is a test, which will get me a string, this is a test, and now change the reference stir1 to refer to that new string, this is a test. So I have not, technically speaking here, modified the string this. What I've done is to create a new string, this is a test, by concatenating this with is a test, and then I've modified my reference, my variable stir1, to refer to that new string. So stir1 is no longer referring to this. Stir1 is now referring to this is a test. And that former value, this, that stir1 originally was referring to, that value is now no longer got a reference referring to it. And so the memory that occupies can be reclaimed within the Python environment for some other purpose in the future. Okay, so a stir is immutable, but the plus gets will work because the plus is concatenation, and the plus gets is really just an abbreviation for change the reference to refer to some concatenation of strings. Alrighty. And now in this next example, we're likewise, we're not using the plus gets, because in this case we want to insert some new string at the beginning. All right, so here we're saying I want to change the variable str1 to refer to the concatenation of really space with what str1 is currently referring to. So str1 here is referring to this is a test. When I concatenate really with this is a test, I get a new string, really comma space this is a test, and now str1 has been modified to refer to that string instead. All right, so in some general sense, as you can see, it's pretty easy to change strings if what you mean by that is to change the strings that a variable refers to. It's pretty easy to change a variable to refer to a modified version of its former value. But what you can't do is a direct modification of an item within the stir. All right, so item sub 4 in the stir, item sub minus 4 in the stir, well, this final character would be -1, so -2, 3, 4. Stirs, sorry, I made a typo here. This should be stir1. All right, I'll need the variable name stir1, not the data type stir. All right, so stir1 sub -4 is this t at the beginning of test. What I'm attempting to do with this assignment is to change that string to really this is a pest. Okay, so changing test to pest. But that's not going to succeed because the stir is immutable. All right. Here we're just demonstrating that because a stir is iterable, we can step through the one item substrings of the stir. This is not a very surprising or confusing example for, let's just replace, let's repeat the display of stir1 just to remind ourselves what it contains. And if I now say for S in stir1, that's going to step through the one character substrings of stir1 one at a time, and I'm going to print out S, and then at the end of each line I want to have a space rather than the default new line. And so I get the contents of the string all on a single line with one space separating each character from the next, each one character string from the next one character string. So those are some stir examples. Here we have some list examples. If I say ls1 gets 1, 2, 3, and ls1 plus gets 4, 5, 6, this works fine, as one might expect. So ls1 now contains 1, 2, 3, 4, 5, 6. Okay. Because a list is mutable, I can also change an individual item within the list. So ls1 sub minus 3 is going to be that 4, and I'm changing that 4 to a minus 3. And a list, of course, is iterable, so we can loop through the values within ls1, and I'm not going to bother to do that one. Here we have a tuple. We're starting out with a single item tuple, 7 comma, okay. And although a tuple is immutable, I can use plus gets with a tuple for the same reason that I could use plus gets with a stir, because the plus gets is really just shorthand here for assigning a different tuple to be referred to by tup1. So when I say tup1 plus gets 2, 3, 5, tup1, not type1, tup1, okay? So that is the same as if I had said tup1 gets tup1 plus 2, 3, 5, and plus is concatenation for tuples, just as plus is concatenation for lists or for stirs. Okay, I don't want to append 2, 3, 5 again. So I'm going to hit Control-C here to kill that off. There we go. But as we know, a tuple is not mutable, so if I attempted to replace tup1 sub 1, which is the 2, with an 11, I would get yelled at. I suppose I should do that just for completeness. Okay. All right, so we've looked at stir, list, and tuple. Here we have some examples with sets. Let me create set1 to refer to 2024. So there's set1. And if I say set1 plus gets 6, 8, whoops, the set containing 6 and 8. Let's see, based on what we've talked about with stirs, lists, and tuples, you might assume that that ought to work fine, because this is going to be treated the same as set1 gets set1 plus 6, 8. But this is not going to work because the plus operator is not defined for sets. We do have 4 operators that are defined for sets. We have the minus for set difference. We have the ampersand for set intersection. We have the caret symbol or the hat symbol for set symmetric difference. And we have the vertical bar symbol for union. But the plus symbol is not defined between sets. And consequently, this ends up being an error. All right, so although a set is mutable, the plus symbol is not defined, and I get yelled at for that. What I need to do instead is to compute the set union of set 1 with the set 6, 8. That gets me back 0, 2, 4, 6, 8. And I can then say set 1 gets. Now, I want to be clear that when I said set1.union 6, 8, that computed and produced a set containing 0, 2, 4, 6, 8. But it did not modify set 1 itself. Set 1 is still just 0, 2, 4. So if I want to change the variable set 1 to refer to that new set, I'm going to have to say set1 gets set1.union 6, 8. As an alternative to using the word union, the named operation union, I could have said set1 or gets, okay? Union gets, okay? The vertical bar, recall, is the union symbol. And let me, all right, so we've got 0, 2, 4, 6, 8. Let me add 10, 12. I was trying to figure out why this blew up. I accidentally said set.union 6, 8 here. And so that eliminated the 0, 2, 4 that were in set 1 to begin with and created a set just containing 6 and 8, although they are displayed in the reverse order for whatever mysterious internal set implementation behavior. So that when I did set 1 or gets, or union gets 10, 12, that worked fine. But I had still lost my 0, 2, 4. So let us try this all again. So I've got set 1 initially consisting of 0, 2, 4. There's set 1. Now I'm going to say set 1 gets set 1. That's where I made my mistake. Union 6, 8. And so now set 1 is 0, 2, 4, 6, 8. And if I say set 1, set 1, not just set 1, union gets 10, 12. Yay, finally. Finally it worked. Okay, so you can see this is a worthwhile lesson. Sometimes code that you write will not produce an error, even though the code is wrong in the sense that it's not doing what you want. And these kinds of bugs in a program can be very challenging to find. So always be careful when you type statements in a program to to double check what you've typed. If I had bothered to double check what I typed here, I would have noticed that I forgot the 1 following set. But I was in too much of a hurry and made a silly typing mistake. All right, so here we are now. I've finally got set 1, originally containing 2, 4, 6. Then I updated it with the union of 6, 8, and updated it again using the symbol for a union with 10, 12. I can also use add, set1.add. Now 10 is already in there. This is not an error trying to add 10 to a set that already contains 10. That's okay. Let me add 3 instead, which is not already in there. All right, and interestingly, in the display, it chose to put the 3 between the 2 and the 4, but there's no guarantee that that might happen. And then here we're doing a set difference. If I say set1 minus gets the set2 6, this is the same as set1 gets set1 minus the set2 6, which means to give me all of the values that are currently in set1 that are not in this set2 comma 6. So what I should get is 0, 3, 4, 8, 10, 12, not necessarily in that order. But I do get 0, 3, 4, 8, 10, 12, and they do happen to be in that order, but that's not guaranteed. All right, so now we've seen stir, list, tuple, and set. We'll talk more about dict in a bit. Which one of these kinds of things can be sliced using the square bracket and the colon notation? Or to say that a different way, which ones of these 5 collections are sequences? Turns out that stir, list, and tuple are sequences, but set and dict are not sequences. Which ones of these things can we delete items from? Well, really, in a way, asking whether we can delete items from a collection is the same as asking whether that collection is mutable. Stir and tuple are immutable, so we cannot delete items from stir and tuple, but we can delete items from list, set, and dict. Now, although we cannot directly delete an item from a stir, we can use a trick involving slices to seemingly delete one or more characters from a stir. I've got stir1 containing, really this is a test. If I say stir1 gets stir1 sub 1 colon, now here I'm requesting a slice of stir1 from item sub 1, which is the E here, all the way to the end, and consequently, I'm modifying the variable stir1 to refer to this slice. Eely, this is a test. So, in some sense, I have deleted the R, but what I've really done is to change the variable stir1 to refer to a different string that has everything in it except for that initial R. I can do the same thing by using a combination of slices and concatenation. I can say stir1 sub colon 4 plus stir1 sub 5 colon. What is this doing? Well, let's see. Where's item sub 4? So here's item sub 0, 1, 2, 3, 4. Item sub 4 is the Y. What I'm saying here is give me the slice of stir1 up to but not including that Y, and concatenate that with the slice of stir1 starting from this comma all the way to the end of the string. And so, in some sense, it appears as though I have removed the Y between EALL and the comma. I haven't technically done that. I have simply changed the variable stir1 to refer to a different string, which is the concatenation of 2 slices of the stir1 that I had previously. Now, using lists, I can directly delete a slice from a string using the del command. So here's my ls1 that I've already got. If I say ls1 sub 1 colon 4, that gets me a slice from item sub 1 up to but not including item sub 4. All right, so ls1 sub 1 colon 4 is going to be items sub 1, 2, and 3. And it turns out that if I say delete that slice, this is valid. And what it does is to literally delete that slice from the list so that the list I have remaining just has the 1 followed by the 5 and 6. Okay, so del is a cool thing to know about. Another way of getting rid of a slice rather than using del is to assign an empty string in place of the slice. Let's see this one. So here's ls1, it's 156. Let me repeat that 3 times. ls1 times gets 3. That's the same as ls1 gets ls1 times 3. So ls1 times 3 means to repeat ls1 3 times, I'll get 156, 156, 156. So now ls1 contains 9 integers. Here I'm selecting a slice from -5 up to but not including -2. Well, let's see where that is. All right, so here's -1, 2, 3, 4, 5. So here's ls1 sub -5, and here's ls1 sub -2. So we're going to access this slice from the -5 item, which is 5, up to but not including the -2 item. And what we're doing is we're assigning an empty slice to that. ls1 sub -5 colon -2 gets replaced with an empty slice, an empty list. Okay, and so there is another way of deleting items from a slice. You can, of course, also use the remove function to remove items by value rather than by index. Dot remove 6. Okay, so that removes the first 6, but leaves any other 6s unaffected. Here's the same kind of trick with a tuple that we looked at using the string. Technically speaking, you can't change a tuple, but you can use slices and concatenation to fiddle around with the, well, actually to create a new tuple and then modify your variable to refer to that new tuple. All right, well, that gets us to the conclusion of this material, and we'll have a brief lab that will give you some practice doing these kinds of operations.